In this video, we'll look at solving trigonometric equations by factoring. So factoring is one of the most useful techniques for solving equations, as we've seen through our study of algebra and trigonometry and pretty much all relevant fields. The idea is simply just to move all terms to one side of the equation, factor, and then use the zero product property, which says that if you're multiplying two things together and that equals zero, then either the first thing or the second thing must equal zero. So we'll look at a couple quick examples. I don't think this needs much more explanation other than factoring is useful. Solve 2 cosine squared theta minus 7 cosine theta plus 3 equals 0. Now you all know well at this point that one of my favorite techniques is substitution. Maybe let's just say for simplicity, let capital C equal cosine theta. So now we have 2c squared minus 7c plus 3 equals 0. I think this always makes it a little bit easier to see what's going on. So now we factor. And this looks to me like we factor into 2c minus 1 and then c minus 3. So now we take 2, and I'll substitute cosine theta back in. 2 cosine theta minus 1 equals 0, or cosine theta minus 3 equals 0. So we have cosine theta equals 1/2, or cosine theta equals 3. Now you may already be thinking, but cosine theta can't equal 3, and that's great. That's good to be thinking, because now we could just get rid of that solution, since cosine never spits out anything greater than 1. So now we'll focus just on the cosine theta equals 1/2. And again, always useful to think about the unit circle. So what angle makes cosine theta equals 1/2? So we can think about a special right kind of on the unit circle. If this is our theta and cosine equals adjacent over hypotenuse, so the remaining side is square root of 3, that tells us altogether that theta equals pi over 3. And there's another angle for which cosine theta equals 1/2. And now in this case, we could either go counterclockwise or clockwise. Let's go clockwise. So the other angle's in quadrant 4, and that's 5 pi over 3. And of course, these are just the solutions for one period. Now we need to write all solutions. So we write theta equals pi over 3 plus 2k pi, and theta equals 5 pi over 3 plus 2k pi. Next one. Solve 5 sine theta cosine theta plus 4 cosine theta equals 0. So for this one, we'll start just by factoring out a cosine theta. So we have cosine theta times 5 sine theta plus 4 equals 0. So by the zero product property, we see that either cosine theta equals 0 or 5 sine theta plus 4 equals 0. So this implies that cosine theta must equal 0 or sine theta equals negative 4/5. Just a little bit of algebra. So now let's do the cosine theta first. Let's solve for all the solutions for theta in this case. The question is, what angle, when given to cosine, makes cosine equal 0? So that says theta equals pi over 2, or 3 pi over 2. And then if we solve for all solutions, theta equals pi over 2 plus 2k pi, and theta equals 3 pi over 2 plus 2k pi. Now for sine theta equals negative 4/5, this sounds to me like a great opportunity for us to use our inverse trigonometric functions. So we'll say sine inverse of negative 4/5 equals theta, and sine inverse of negative 4/5 gives us theta equals negative 0.93. Now don't forget that there's more than just this one solution. So remember our unit circle, like this. And if this is the angle, maybe roughly here, this angle are theta equals negative 0.93. This is the angle that gives us negative 0.8. Then there's this other angle here, right there, that also gives us negative 0.8. And that angle, we just take the reference number and subtract it from pi. So we say theta equals pi minus negative 0.93. So that gives us roughly 4.07. And then accounting for all the solutions, we have theta equals negative 0.93 plus 2k pi, and theta equals 4.07 plus 2k pi. So those are all the solutions for this particular equation. So we have theta equals pi over 2 plus 2k pi, 3 pi over 2 plus 2k pi, negative 0.93 plus 2k pi, and 4.07 plus 2k pi.